Hello everybody, welcome to the 10.3 video on the second part of the video on surface area of cylinders. Yesterday you learned about surface area of prisms, of rectangular prisms and triangular prisms, but today we're going to focus on cylinders. Okay, so yesterday, just so I can show you a couple things, you did pyramids and prisms. So if we had the surface area of a pyramid here, we could figure out that the shapes that we have to add up are triangle, 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 so 4 of those, and then a square in this case. Or if we did a different prism, possibly we did a rectangular prism, we could make the net of that prism and add up all the different sides, all the areas of all of our sides. The hardest part about it is visualizing it and seeing how it would come apart. But here we'd have to add up the area of 6 different rectangles. But cylinders are definitely the hardest of the 3D shapes, most people think, to make the surface, to find the surface area of. So in class we've talked a little bit about what shapes this cylinder makes. We can obviously see the top circle. Sorry, it's a little blurry there. The top circle and the bottom circle. So that would be 2 of our shapes, circle and circle. But as we talked about in class, the middle shape is actually this band here that goes all the way around. If you think about a label of soup or something like that, you unfold it and it actually is a rectangle. And I've showed you this net a couple times in class, but to get it started here is a cylinder. And if we actually unfold this cylinder, you'll notice that what happens is you get 2 circles and a rectangle. So those are the 3 shapes that we're going to add up for our surface area. 2 circles, and they're identical circles because they're right on top of each other. The bases are congruent in any prism or cylinder. So here, the 2 circles, we can just find the one and double it, and then we're going to find the area of this rectangle. But what you should know by now is that the circumference of this circle, if you measure the distance around here, it would be equal to the distance from here all the way over to the other side. Okay, I should have brought a piece of string and actually measure that out. Oh, here we go. Let's try this. Quick little measurement thing here, just so you can see. If I put a piece of string around this circle, if you can see it, put it from here. This is harder than it looks. All the way around. It won't be exact. Sorry, I should have planned this out better. But all the way around here, if I can get it out, I'll kind of estimate. There we go. So about here to here. So if I pull this here, I'll have to cut it. We'll be close. Not quite accurate, but close. If I had scissors that worked. There we go. Okay. So this is about the circumference, and if you see that, it actually does go all the way from end to end there. Okay. So the circumference of our circle, we can find if we just know the radius halfway across. We can find that using our formula, and it'll give us the length of a rectangle. So if we find the length of a rectangle, multiply it by the height, we'll get our answer. So if we kind of switch back here to your notes, we're going to go ahead and first draw the net of our cylinder that I just had there, that orange net. So the net of a cylinder is 2 circles and 1 rectangle, and they're kind of touching each other. So let's go ahead and make that net. You can go ahead and do that while I'm getting started here. Alright, so the net of our cylinder is going to look something like this. We have a rectangle, and then we have 2 congruent circles. So the circles are kind of the same exact copy of each other on top and bottom. So if you notice, your circle, your cylinder can look kind of like that. You could even put the net on the circles on the other side, so when they fold around, they would still match up. They don't go on the opposite sides, though, because if you think about that, that wouldn't work when you actually roll it back together. Typically, the circumference, if I highlight that for you, this circumference of your circle is equal to this distance. So you kind of have to eyeball it and make sure that the length of your rectangle is close to equal to the circumference. So the lengths of that circle and the length of that green line have to be equal. So here is the net of our cylinder. And I want you to actually label what we know. From here to here is what's called the circumference. And it's the circumference of our circles there. We obviously know that our circle has a radius of r. But the second part that we didn't talk about yet is that this distance right here is the three-dimensional height. It's how tall our cylinder is. So if you look at the first example, it's here to here is the height of your rectangle. So our cylinder is made up of a circle, and those are equal circles, congruent circles, and a rectangle. And I want you to kind of talk about that the rectangle is going to be made up of the circumference, this distance here, times the 3D height. Circumference times height. It's not just base times height for a rectangle, because the base in this case is actually the circumference. So we'll go ahead and look at a couple examples. We have one cylinder, we're given the radius and the three-dimensional height. And in the second one, number 4 there, we are given the diameter of our circle and the 3D height. And notice I still said that this is the height because it's actually just on its side. The height's not always up and down. The height is the distance between the two bases. And it's sometimes you can't see the back side there, but this is actually the height here. Sorry, a little glitch there. This distance is the 3D height. So from base to base. So we'll look at a word problem as well, and then answer this question. Why do you need the circumference when you're finding the surface area of a cylinder? And hopefully that question starts to make more and more sense as we do some examples. So example number 1. If we draw a quick net of this figure, we're going to draw the rectangle in the middle, and then we have 2 circles. So the rectangle and 2 circles will make our net. So the circles come up here. And what we're going to do is find each of these areas, the circle, and the rectangle. Let's start with our circle. The formula for a circle is pi times r squared for area. So we're going to do pi times r squared. In our case, this is pi times 4 squared. So once we do that, we'll do pi times 4 squared. And you can type that onto a calculator. I'm going to actually use the pi button. Pi times 4 squared. Double check me on this. I got 50.3. And I'll round to 1 decimal place for each of these stages. My next circle is exactly the same, pi times 4 squared, 50.3. The rectangle is the circumference times the height. So we actually have to find the circumference, which remember is this distance here. I'll outline it in red. This is circumference times the 3D height. So this 3D height is the distance from the 2 bases, and it's a 10. So to find the circumference, you have to do a different formula. The circumference formula, c times h there, circumference is pi times diameter, and then we'll multiply by the 3D height. This part right here will give us the area of that inside rectangle right here. Okay, so pi times diameter, here our diameter is, doubling 4, we get 8, and our height is 10. So pi times 8 times 10 is 251.3. So what we have to do now is add up all the 3 parts, the circles, and then the rectangle. So the circles, I'll do that one at a time there. The first circle is 50.3. The second circle is 50.3. They're the same. I should have done the same color actually. And then the 3D height is circumference times height there. Or the area of the rectangle, sorry. So 50.3 plus 50.3 plus 251.3. Lots of point threes. So what we end up getting is 351.9. And our units here, we didn't give one, so we'll just say units squared since we're dealing with surface area. So area there. All right, next part. Once again, we're going to do the same type of thing. This cylinder is laying on its side now. So for this one, we still have to label everything that we have. We have two circles and the rectangle there. So the circle has a radius of actually just 1. Half of 2 is 1. So we'll do pi times 1 squared for both of the circles. Pi times 1 squared, well, 1 squared is just 1. So really it's just pi times 1, which is pi, or 3.14. So both of those are 3.14. The rectangle is circumference times height. So the circumference, we're going to do pi times diameter, which is pi times 2 in this case. And our three-dimensional height, remember, is from base 1 to base 2. So it's the circle to the circle, and that distance is 3. So we're really going to multiply this by 3. So when you multiply pi times 2 times 3, you end up getting 18.8. So what we have to do is add these numbers together. Again, let me do that in a different color here. The two circles are the same, 3.14. That's the area of this guy and this guy. Or, you know, on the 3D shape, it's this thing and this yellow thing here. And if we do the other part here, our rectangle is the circumference times the height. So we did circumference times height to get the area of that rectangle, which on our 3D shape is just the distance around this whole thing, both sides. So the final answer, when we add up this, and this, 3.14 plus 3.14 plus 18.8 is 25.08. And this time it's yards squared. 25.08. All right, next one. I'm going to give myself some more space here. It says Carson wants to make a cylindrical pillow for his mother's birthday. Mother's Day is coming up in May, so he needs his birthday present earlier. Or Mother's Day present. Oh no, sorry, birthday. Forget what I said. The pillow was to be 15 inches long and a diameter of 6 inches. So I'm going to make a new shape here of my pillow on a different page. Alright, so here's our pillow. Cylindrical pillow. And we'll kind of just make that a little bit bigger here. We'll connect our sides here. It was 15 inches long. This isn't going to be perfect, sorry about that. But well, 15 inches long and then diameter of 6. So we'll copy and paste that. So here's our pillow, basically. And if I put the dimensions in here, we want to basically figure out how much fabric we need to make. So once again, the dimensions are 15, and then 6 inches as the diameter. So to find the surface area for this pillow, we need to break it up into a circle, and the rectangle. The circle is the easy part. The radius of each circle is just 3. So we'll do pi times 3 squared for both of them. And then the rectangle, when we unfold that, remember that the net is the circumference along the base alongside there. So it's circumference times height. So when we do pi times 3 squared, double check the math here, make sure you can actually follow along with me, not just write down what I'm going to write down, but double check it, make sure I'm right, because I've been known to make mistakes. We have 28.3. It's the same circle, those should always be the same. And then circumference times height. The circumference, once again, is pi times diameter, so that's 6 times pi there. And the height is our distance from bottom circle to top circle there, so that's times 15. When you do the math there, you get 282.7. So when I add my three parts together, circle, circle, and rectangle, we add those all up, I got, oh, sorry, I didn't add them up yet. Well, this gives you time to do it here. 28.3 plus 28.3 plus 282.7. I got 339.3. And that's in, square inches of fabric. That's how much you would need to make that pillow. When you come in tomorrow, I'd like you to have this question answered on the bottom of your page here. And it should be pretty clear at this point why. But why do you need circumference when you are finding the surface area of a cylinder? Thanks for listening, guys. We will see you tomorrow.